We will now look into the calculation of density of unit cell. Let the edge length of unit cell be A, molar mass be M, density be D, Avogadro number be Na, and the number of atoms in a unit cell be Z. So all these entities are linked by a formula, that is D is equals to Z dot M by A cube Na, and the density of the unit cell is same as the density of the substance. Today we will start with the new topic of solid state, that is Bravais lattices. Bravais showed that there can be only 14 possible ways to arrange the points in a 3D space which are similar. So the Bravais lattice, depending on the shape of unit cell, are simple or primitive lattice, body centered lattice, face centered lattice, and end centered lattice. In simple or primitive lattice, the points are there at each corner, so there are 8 points at 8 corners. In body centered lattice, points are there at the corners plus there is a point at the center of the body. Then face centered lattice, in which the points are there at each corner and there are points at the center of each face. And end centered lattice, in which the points are there at each corner and at the end faces. This model is theoretical model. Now we will look into the calculation of atom in a unit cell. The first is primitive cubic unit cell. In primitive cubic unit cell, each corner, that is 8 corners, are shared by 8 atoms. So 8 into 1/8 will give 1 atom. That is 1 atom is constituted in primitive cubic unit cell. The next is body centered unit cell, in which 8 corners are shared by 8 atoms plus 1 in the center. So it will be 8 into 1/8 plus 1, that is 2 atom is constituted by body centered unit cell. Third is face centered unit cell, in which 8 atoms are shared by 8 corners plus 6 face centered atoms shared in 2 unit cell. So it will be 1/8 into 8 plus 6 into half, that is 4 atoms are shared in face centered unit cell, or 4 atoms constitute the face centered unit cell. Now we will start with the new topic of solid state, that is closed packed structure, 1D structure. 1D structure is simple structure in which atoms are arranged side by side. Its coordination number is 2. Coordination number is defined by the number of atoms surrounding that atom. Second, 2D structure. 2D packing can be done in 2 ways. First, square close packing, and second, hexagonal close packing. Square close packing has a coordination number of 4 and it gives AA type of packing, in which all the layers have the same arrangement. Hexagonal close packing gives the coordination number of 6 and gives AB type of packing, in which the second layer is present in the void of the first layer.
Thank you for watching. Visit us at needbook.in.